So basically, partial derivatives are like derivatives, but you need to take the derivative of a multivariable function. So you just take it partially, and then you can take the gradient of a function, and that it gives you a vector field of vectors and stuff, and that just like gives you a cool vector field that can look cool on a paper. So in partial derivatives, you just take the derivative, but you pretend all of the other variables are constant, and the one you don't pretend is constant. You have partial f, partial, let's just say x, and you need to take the derivative of f, where f is so f of x and y. It takes a y input too. Equals let's just say cosine of xy. So the derivative of this is basically the derivative of x times any constant. I just choose a simple constant like 2 or something, so I just pretend like y equals 2, but you can't simplify it. So that is equal to, let's say, wait, no, not let's say, that is definitely equal to, oh my gosh, my sisters, that is definitely equal to, so you pretend it's a constant, you use the chain rule, you get negative sine xy times y, because you have to multiply by the derivative of this with respect to x, and since it's just with respect to x and y isn't anything, then you end up with, well, without x, because x becomes 1. So let's get rid of this. So let's take the derivative of the same function, so cosine xy with respect to y this time, so partial over partial y. Oh, dang it, I made the y too big. I don't care. So still negative sine, but this time it would be x on the outside because y becomes 1. So there, that's it. And then you to take the gradient, written as nabla f, or whatever function, equals, so let's draw a matrix right there. Oh dang it, I probably made the matrix too small. Let's make it bigger right there. Okay, so I'm probably just gonna take this, copy it, put it. Yeah, it's too small, but pretend it isn't. Okay, I'm just gonna. Dang it! Sorry. And then we'll take this. And xy, and then you multiply it times y by y, and let's move all of this here. So that's like how to take a gradient and a partial derivative. I know that was really short, and yeah, I don't care. And let me just get rid of this. So yeah, that's like how to take the partial derivative and a gradient. Just so this video isn't that short, I'm gonna take another gradient of a different function. This time, how about, crap it, equals, f equals tangent of x to the y. So, sorry guys. Okay, so take the partial derivative with respect to x first, so that would be secant squared of x to the y times yx to the y minus 1 based on the power rule. So that's the first thing. Sorry about my sisters. So let's gradient of f equals, so then we'll just do the same thing but with respect to y right there. Secant squared of x to the y times the natural log of x times y x to the y. And that's basically the basic idea of partial derivatives. I'm not gonna go any further into it because I do not have a script and I recorded this out of my own boredom. At least I'm being honest, so.